Let's go ahead and go over the this is Math 5, quiz number 5 on sections 3.3 and 3.4, taken on November 2nd, 2017. The quiz itself was out of 38. Directions: show all your work in space provided, box your answers. So for the first 8 questions, what I decided to do is just take the cutouts that you actually did in class. So we actually did all of these. You already knew all the answers. I give it back to you to see if you're paying attention. Some of you guys are just writing down answers, and some of you guys are just filling out stuff to get credit, but you don't understand. That's why I give it back to you. Do you actually understand it? Match the following by putting one number per blank. Yes, there are 2 extra numbers that are not being used. 2 points per blank. So if you actually took number 1 and you graphed it, you get these points here. So negative 1, 1.73, negative 1, negative 1.73, so exactly below it. And you realize that's happening 0, 2, which is a little bit above this one, 0, negative 2, and you keep going. You have these 3 points and these 3 points. Well, basically it's a circle. Now you know this is not a function. Each of these are part of the function family. So if you had to add another column over here, which I didn't do, I wanted to really make sure you knew it, this is the neither. It's a neither because it doesn't pass the vertical line test, right? If I put my pencil here, it's going through 2 points there, so it fails the vertical line test, therefore it's not a function. So these are all functions, this one's not. So if you had to, you could put another column right there. Question number 2, I have f of x equals x plus 5 times x plus 1. For this problem, you see that there is multiplication here. The student that's going to repeat the class, they're probably just going to multiply the first terms and the last terms. That would be wrong. You can use an acronym, FOIL, or you can use my method, which is called the area model. Take x plus 5 and x plus 1. You're going to multiply first, and then you're going to add or combine like terms. X times x is x squared. 1 times x is x, x times 5 is 5x, and 1 times 5 is 5. Put a 1 right there. Those are my like terms. X squared plus 6x plus 5. Because it's the power of 2, this is quadratic, so 2 is quadratic. Question number 3. This is actually a graph of this picture over here. No, it's not. Just kidding. But you realize it also fails the vertical line test, so it's not a function, so you can put this one over here if you want. Question number 4. Louise heard a rumor. She tells the rumor to 2 people the next day. The 2 people that she told then tell 2 more people the following day, and who each then go and tell 2 more people the rumor of the following day. The relationship between the days that have passed and the number of new people who hear the rumor. So I said after 0 days, so I got words, I got a verbal, I'm going to make a table or a numerical to help me kind of see this. Here's Louise, day 0. She goes and tells 2 people. So Louise knows it, and then she's going to tell 2 more people. So those are the 2 people. So in total on day 1 of new people is 2 people. Day 2, this person's going to tell 2 more people, and this person tells 2 more people. Then you have a total on that day of 4 new people. I recognize that you can't add, and there is no second common difference. It's multiplying. So there, because it's multiplying, that's exponential, common ratio. So 4 goes under exponential. Question number 5, if I look at this graph, it's smooth, it increases or decreases very quickly. That's exponential, so that would be a 5 there. Number 6, you have a line, which they call linear, so that would be number 6 goes there. Number 7, Erica is worried that her secret got out. On the first day, she and her best friend were the only people who knew about the secret, but now 2 new people are finding out the secret every day. Every day is a key word. the relationship between the number of days that have passed and the total number of people who know about her secret. You're basically here, the 2 new people, that's adding every day. That's just linear, first common difference. And if I did question number 8, here you realize that they're skipping. Do you guys see that? Do you see how it's not -4, -3, -2, -1, 0, 1, 2? They skip some numbers in here. So what you could do is you could just expand yours and see what's happening. I have a -3 here, and you realize that down here, when there's closer numbers, there is no from 5 to 12. I'm adding 7 and here adding 9. So if you go backwards, add 5, add 3, add 1, add -1, and then you fill in your chart. And you realize that these numbers are not the same, so it's not linear. And then if you keep going down, you realize that you have a second common difference of adding 2, so that would be quadratic. Now if you see a mistake up here, you could have put in this column right here 7 and then 6. After class, take a picture and then send me an email saying, Mr. N, can you look at question number 1? I should receive more points. Remember, I do have electronic scans of every part of your quiz. So each of those blanks are worth 2 points. So 6 times 2 is a total of 12 points, and now you're only getting 1 point for writing your name. Question number 2. I broke up, if you recognize, a lot of these actually came from the worksheets we actually did in class. So you had the questions ahead of time. We've gone through it, you had time to ask questions, you had time to come in after school to ask questions, and a lot of students aren't asking questions. Model this scenario using 3 things, and each of these 3 things are worth 2 points. A public broadcasting station distributes 16 coffee cups each day. So here's another keyword. Anytime you see the word every or each, or if you're working, right, one of my students is working at a candy store making $10 per hour. When you see the word per, every, or each, automatically it's going to tell you it's linear. The reason why is this is your slope, your constant rate of change. 16 cups per day is your slope of the fundraising drive to individuals who donate at least $75. I cross off the $75 because it's information you don't need. During the fundraising drive, 12 people declined the coffee cup. So imagine every day I'm passing out 16 cups. In total, though, only 12 people are saying no. The 12 people are saying no, that's the -12. From all the number of cups that are distributed. So right here, you realize that if you day 0, you didn't have to start at day 0, but I think it's best to always have 0 in there. So what's happening is from here, on day 0, you passed out 16 cups times on day 0, so no cups are really passed out, but there's still a -12. And actually that explains why your graph starts way down here at -12. Then on the first day, it's 16 times 1 minus 12 gives you 4. Second day, 2 times passed out 16 cups per each of those days, and then subtract 12, you get 20, and you keep doing this. And you realize when you do this math operations here, you're going to get a pattern, and then it doesn't matter what you put in here. If you put an n, you can have 16 times n minus 12. See that? So if you got these numbers correct, you got 2 points. If you graph these points correctly, not that one, that one, then gave you another 2 points. And if you had your equation or function, so go ahead and write that. Equation is the same thing as a function. So table, graph, and then your equation. You can get that from here, the table, or you can create it from the slope-intercept. So when you're doing a problem like this and there's multiple parts, doesn't matter what class you're in, English, history, math, go ahead and put check marks after you've completed it. I've noticed a lot of students didn't do all of the parts there. Alright, how did I score you partially on this problem? The table, if you got anything correct on here, I gave you 1 point. On the graph, if it looked linear but it wasn't the exact points, then I gave you 1 point. And if your function, a lot of students wrote 16x, then I gave you guys 1 point. That side was worth 20 points. Alright, on the back side, this is question number 3 here. It says, before I tell you how to do the problem, I wrote SP over here. This actually came directly from your skills practice packet. And the reason why I take problems that we've actually gone over in class, or it's homework, or something you've seen, is to figure out if you really understand it. Not memorize the answer, not just going through the motions, but do you understand it? Okay, I'm not even giving you a brand new problem to apply it. Sometimes I'll just give you the same exact problem. Complete each table, graph, and function. So there are 3 things they want us to do. The Photography Club tracks the number of photos its members have published in the school paper over the course of 1 year. The total of photos published can be represented by the expression 2m squared minus 5. So 2m squared minus 5. The table lists the total number of photos published. Okay? So it gives me over here 4, 5, 6, and over here 3 and 13. So I can just go up 6, 5, 4, then I wrote 3 and 2. Then I'm going to use this expression 2m squared minus 5. And for every n value, I'm just going to put in the number of months since you're starting. I'm going to put in there for the n value. Does that make sense? I put in a 2 there, 2, so their order of operations, 2 squared, so you're doing the exponent first, that's 4, 4 times 2 is 8, 8 minus 5 is 3. 3 squared is 9, 9 times 2 is 18, 18 minus 5 is 13. 4 squared, that is 16, times 2 is 32, minus 5 is 27. 5 squared times 2 minus 5 is 45. 6 squared times 2 minus 5 is 67. So, in doing a problem like this, look at the directions, put a check mark every time you complete something. So I've completed the table. Now I need to graph this. The nice thing about this graph, it already has the x-axis and the y-axis labeled for me, and it tells me the numbers already. So you just have to graph it. 2, 3, 3. So it's counting by ones here. So this is a 1, that's a 3. Does that make sense? Counting by ones. And these are counting by 4s. 4, 8, 12, 16. So I have 4, 27, 5, 45, and 6, 7. Now here's a common mistake students did. You should be using a ruler. And if you used a ruler on this problem, you realize that it's not linear. You were taking a point off if your graph has a straight line. The reason why is because it's to the power of 2, it's quadratic. Another way you know that is that there's going to be a second common difference. Okay? So that was the second thing you were to do. So you were supposed to graph the function, and then, whoops, third over here is label. All you have to do, these are the x's, time since start of year, measured in months. If you missed a part of it, like you didn't write the units, months, I took a point off because you didn't tell me what these numbers represent. Over here, this is total number of photos published. Okay? And your hints are, this is the x-axis, this is the y-axis. Okay? So that was 6 points for that question. Question number 4 was also in your skills practice. Complete each table, so there's one thing to do. Then graph it, second thing. Then label the axes, third thing. And then fourth, write a function or equation. Gary is cooking appetizers to prepare for a party. For each appetizer, Gary needs 20 minutes to prepare. So the word each, okay? Each, the word per, you make $10 per an hour. Per means a constant linear rate. Constant rate of change, that's linear. So those are your hints. Gary needs 20 minutes to prepare. So 20 times every appetizer. 20 times every appetizer, we'll call each appetizer X. So if you put in 2 appetizers, that means he needs 2 times 20, 40 minutes, right? And that's what the table says. The table lists the amount of preparation time Gary will need to, for different numbers of appetizers. How many minutes of preparation does Gary need for 5 appetizers? Okay, so let's just say I made the problem more difficult. Look, the table is to help you so you can even make a table for yourself. The numbers are already there, 1, 2, 3, 4, 5. If you don't have yours, always pick 0. So again, if I made the problem harder and I just took away all of this, make a table for yourself. Complete the table, 1, 2, 3, 4, 5, and then what happens there? Well, here I'm adding by 20 on each of those. That's a first common difference, that's linear. Always start with 0. The reason why you want 0 is because it tells you the y-intercept. Very helpful for graphing. So I finished my table. All I had to do there was put 100. The second thing was to graph it. Well, I just take these ordered pairs. I got 0, 0, 120, 240, 360, 480, and 5, 100. So on the graph, you actually had to make yourself. It was blank. So I just used the bottom here. And I've designated each one of these as 1. So every 2 boxes was 1 appetizer. You could have done 3 boxes. You just want to make it look nice. You don't want to make it cramped. And I realized I was counting by 20s, so I have 0, 20s. So 20 represents 2 boxes. And then you can just make a line here. Now, mathematically, the reason why I didn't want to connect the line is because the answers are discrete. What does that mean? You don't have half of an appetizer, and we don't say it takes you 10 minutes to do half of an appetizer. You just want to know how much time does it take if I have 6 appetizers, right? Quesadillas, buffalo wings. Third thing was to label the axes. So again, this is the x. You're writing number of appetizers, and this is the y coordinates. It's alphabetical, right? This is the y. Y is the vertical. Amount of preparation time. Don't forget the minutes. Okay? That was the third thing. The fourth thing is write a function or equation for each. Okay? So over here, at the end of your table, some students write the letter n. Perfectly fine. Well, how do I get to that? Well, it's 20 times that value. 20 times that value. 20 times that value. Do you see the pattern there? And this is the advantage of using a table. So then, here, I have 20n, or if you use slope-intercept form, slope was 20. In front of the x, and your y-intercept is 0 because of that ordered pair that I told you guys to use, right? So when you write your equation, you could have f of x equals 20x, you could have y equals 20x, or y equals 20n would have been acceptable. So 2 points apiece, and that would have given you a total of 8. And the last problem, algebraically prove that x minus 1 squared and 2 times the quantity x squared minus x squared plus 1 are equivalent. So the question is, are they equivalent? Are they equal? X minus 1 can be written 2 expressions, x minus 1 and x minus 1. Here you can use FOIL if you know how to use it, or you can take each of these and write them on the sides of my square. This is a binomial 1, 2, and another binomial 1, 2. And here you're going to multiply first, and then you're going to add or combine like terms. X times x is x squared. X times -1, -1x. X times -1, -1x. And -1 times -1, positive 1. That's multiplying. Then adding or combining like terms here, I need to add those. So I have x squared minus 2x plus 1. The most common mistake, let me write that, common mistake, is just to multiply the first ones and the last ones. And they get x squared plus 1, and this is wrong. No, don't do it. Right? On this side, you just distribute. So 2 times x squared, 2x squared, 2 times -x, -2x. And then here I'm just combining them like terms. Here this is a -1, so 2 and a -1 gives me a positive x squared. Here there's no like terms, and this one doesn't have a like term either. So are these two equivalent? They're exactly the same, then that is true. I had one student show me another way of showing their equivalent. The student actually picked a number, such as 1, and put in 1 for both sides, and does it equal the same number? Yeah, that I gave you credit, but for the test tomorrow, I want you to show it to me algebraically. I'd rather see you distribute, multiply, and simplify. Okay? Oh, I wanted to show you guys another common mistake. You cannot, don't do this, you can't distribute the exponent. That will give you x squared minus 1 squared and then x squared plus 1. This is wrong. No, don't do it. So this problem was out of 4 points, and if you got one side correct, I gave you 2. That side was out of 18 points. And that's 20. If you add those up together, you have a total of 38 points. Hope that was helpful for you to study.